Vlsi lab. So now let's see how to do the schematic of common source amplifier. So here we are going to use the single stage common source amplifier. So for that, first let's open the java.jar electric 9.07.jar. So this is the tool we are going to design the common source amplifier. So just go to file, create new library if you are new to this video, or else just watch the starting of this video, that is the inverter, designing of the inverter for this software introduction and how to install all those things. Just watch that video. So if you're starting from here, go to the new library. So I'm just going to open my library we already created, and we already created the inverter and the NAND gate. So these are all the things we just made in our previous videos. So NAND gate schematic and the NAND gate layout. Now we are going to create the schematic of the common source amplifier. So create new cell and here select the schematic and here select common source CS amplifier. Okay, so then click OK. So now we have the schematic window here. I'm just going to zoom this and grid on, Control G. So for the common source amplifier we need the 2 PMOS and 2 NMOS. Okay, so here is the PMOS. I'm just going to select this and let's zoom this. Okay, so okay, it's zoomed completely, that's fine. And even we need to have the another PMOS. Okay, so we need to have the another PMOS here, and we need to have the 2 NMOS. So 1 NMOS. Okay, I will just make the zoom out 1 minute. This one we need to have it here, and yes, and another NMOS we need to have it here. Okay, so just properly arrange this, and these two, that has to be okay. So let's just rotate this one so that, yeah, rotate like this one, and this also rotate like this. Okay, yeah, like this we need to rotate, and we need to okay, so now we have something like this. Just properly arrange all these things, and this one also we can rotate outside. Okay, so now we have the structure, this basic structure like this. So now just and another thing is we need to have the ground. Okay, so another thing is we need to have the ground over here, and VDD. So this forms the common source, and here we need to have the VDD. So VDD we are just keeping here. So now we need to connect these two, that is from here to here and from here to here, and even we need to connect these two, and from here to here, and from this one to this, and from here to okay, so let's just connect it here, and from here to here. Okay, so we just need to connect like this, and here the supply, and the ground has to be connected from here to here, and this one we need to connect from here to here, and we need to connect the ground for this one. And okay, so we have the structure like this, and we are going to take the output from here. So this is my output. So from here to here we need to take the output, and here that is the bias, we need to give bias voltage. So for that I need to have the voltage source. So or we can just give the terminal, and we can give the voltage from the spice code. Okay, so this is my V bias, and this is the V output, and here I need to give the V in. Okay, so we need to give the V in. Just rotate this, and here we need to give the V in. Okay, so now this is V in, this is V bias, right? So just control expert and V BIAS, V bias, and just select this as a input. Okay, so this is the constant bias input, and that is connected here, and this one is control export, and here V in. So this one, this is the input. Okay, so yeah, this is the input, and this is the output, control expert V out, and here we need to select the output and click OK. So this is the output, and the length and the width. So here this is as per some calculations, so I did this calculation. Okay, so here for this one the width has to be, okay, length and the width. So width has to be 5 and the length has to be 25. Okay, so for these above two, the length has to be 25 and width has to be 5. Okay, so then click OK. So then here also width has to be 5, length has to be 25, and for this one the width is 10 and length is 2, and here the width is 20 and length is 2. Okay, width is 20 and length is 2. So these values I am going to provide in the description. Okay, so this is what the basic structure, and another thing is we need to create like set spice model for these things, set spice model. So this is the PMOS, and for this one also go to tools, set spice model, and here we need to select. Okay, so only select this, and this is PMOS. Okay, so this is PMOS, and this is V out. Let's place that here. So these two are the PMOSs, and here we need to have the create expert for the NMOS, tools, set spice model, and this is NMOS. So just have it over here, and NMOS, and for this also go to tools, simulate spice, and set spice model, and okay, so just have it over here, and NMOS. Okay, so now we set the spice model for these two MOS. So now go to tools, and once check the DRC. Okay, so it found one error, that is the somewhere the wire is overlapped or something happened. So okay, CS amplifier and unnecessary diagram, just delete this. Okay, simply press the delete button. So now it will be error free. Okay, so now there is no any errors. So after this we need to write the spice code. So go to components, and go to MISC, and here spice code, and have it over here, and just Control I and click multi-line text, and here so first thing we will define all the constant voltage sources what are here. So one is the VDD, so VDD 0 DC, VDD okay, so VDD 0 and DC and 5. Okay, so VDD, this is the name of this voltage source, and this is connected between VDD and ground, and this is of the type DC, and the voltage is 5 volt. So this is one. Okay, so and another thing is V bias. So V bias, it is the name V bias which is connected between VBIAS. This name you can give anything, it is need not be V bias, but it has to start with V, that's it. Okay, so for simplicity we are giving V bias only, V bias, and it is connected between terminal V bias and ground. Okay, so we can give 0 or GND. Then this is also constant DC supply of bias voltage is 1.2 volt for this design. Okay, and after that we need to do the 3 types of analysis on this circuit, that is transient and DC analysis and AC analysis. So transient analysis, transient analysis. So this is to represent the comment, the asterisk marks we can use, transient analysis. Okay, so one analysis is this one. So for transient analysis we just need to, okay, so what we need to give, we need to give the V in. So this V in we need to give some values. So this V in, so V in 0, and so we need to give the AC signal for the input. Okay, so a small AC voltage we will give in this amplifier, so we can see exactly the how waveform is, sine wave we are going to give. So V in, this is the same syntax, 0 and sine, sin, sine. Okay, sin, V in 0 and sin. Then we need to specify the 3 values, that is first one is the DC offset. So DC offset means yeah, this we will give as a 0. So DC offset, and the amplitude let's give as a 1 millivolt, and the frequency is 1 kilohertz. Okay, so just remember this syntax. So this is V in, this I hope you know, V, and here is the name of that voltage, and here is the 2 terminals, that is N plus and N minus, and what type of voltage is this. So it is the sine voltage. So sine means here we need to give, so first one is the DC offset, and then is the amplitude, and then is the frequency. Okay, so 0, 1M, 1K. After that we need to make the transient analysis. So for that dot TRAN, and how many times we need to run this circuit, for example 100 N, that means 100 nanosecond we are going to run this circuit. Okay, then we need to do the DC analysis. So DCANAL. Okay, so DC analysis, and here we missed one thing, V in 0, and here we need to give AC. Okay, 0 AC, then the AC voltage value. Okay, so 0 AC, then the AC voltage values. So yeah, exactly, V in 0, and here the type. Okay, v in n plus n minus, and here is the type. That means whether it's the AC or the DC voltage. Then we are giving the sine. Okay, sine command. So don't confuse between that pulse command and this sine frequency. So here the type is AC. It is of the kind sine. In the pulse command, it is like directly after n minus, there is no DC and AC. Pulse means it is always DC waveform pulse. So directly we need to give pulse command directly here, pulse. But here type, that is AC, and SIN 01N, like this we need to give for the transient analysis. Okay, 100 nanosecond. Then for the DC analysis, okay, so we will just write the spice code here and we will analyze one by one in the LT spice. So for the DC analysis, so here this V in, we need to give the DC voltage in terms of steps. Okay, so in terms of the steps, so remaining these VDD and V bias will remain as it is constant. So now for DC voltage, this V in we need to give as some DC values. Here we gave in transient, we gave V in as the AC. Okay, but in DC analysis we need to give V in 0 DC, and we need to give the DC values. So we will give this as a 5. Okay, so we need to give, and we need to increase the, okay, this one we just need to give, otherwise it will give the error. V in is not given anything like that, it will give. So then we need to increase this V in terms of steps. Okay, so DC analysis means like that. So V in we are increasing in terms of step of some 0.1 or any values, and we are seeing how the output will change. So for that dot DC, what pin we need to use for the analysis, DC analysis? That means we are changing V in dot DC V in, that is from 0, it has to go from 0 to 5 volt in terms of 0.1 steps. That means 0.1, 0.2, 0.3, like that it will go from 0 to 5 volt. Okay, so this is the DC analysis. So only the two lines will be there for this transient analysis as well as this DC analysis. One is V in 0 DC 5 dot DC V in 0 DC 5, and another thing is the AC analysis, AC ANALYSIS, AC analysis. So for AC analysis, okay, so for the AC analysis, we need to give the AC values for the V in. So for this V in we need to give the AC values. So for this one, V in 0, so okay, so 0, then 0 AC, and same, that same, okay, sine of, so here DC offset voltage we don't know, simply I'm giving 1 0 1 M and 1 K. So these values, okay, for the to find the amplifier's phase and its frequency, and even for the to find its cutoff voltage of this amplifier, first we need to do the transient analysis. Then we need to find at what, okay, so first we need to do the DC analysis. Then we are going to find its cutoff voltage. That voltage we need to write in the DC offset, like this sign here. This DC offset is there, right? That means we need to have this DC analysis at the first. Remember, first we do the DC analysis, then transient analysis, then AC analysis. Because in transient analysis and AC analysis, for this sine wave, DC offset, okay, this DC offset simply I kept as 0, but this value we need to find from the cutoff voltage. Okay, so here this 0 is the cutoff voltage. This 0, I wrote here 0, right? Actually we need to replace this 0 with the cutoff voltage, that we need to find from the DC analysis. So here also. Okay, so then for this AC analysis, dot AC, then DEC, that means increment in the decades. Okay, so DEC, and so the values from 100, that means hertz, these frequencies we need to give 100 to okay, so 100 and 10 G. So till 10 gigahertz we need to, so that means it has to decade, it has to sweep by the decades. DC 100 sweep by the decades, and 100 to 10 gigahertz it has to sweep. Okay, so this is the AC analysis. So this is DC transient and AC analysis commands. So we just have only the DC analysis and remaining everything in the comment. Okay, just comment it down. Okay, so then click apply and click OK. So now we have the all these codes here, spice codes here. Now go to tools, there is no any errors, so go to tools and go to simulation spice, write spice deck. Okay, so cannot find definition of model NMOS L400. Okay, so that means we not added the C5 models, that's why it is giving this error. So again edit this, we just need to have, okay, and directly you can edit here, or else Control I, we need to have dot include C5 models dot txt. This file we need to have. Then click apply, then click OK. So now go to tools, set simulation spice and write spice deck. So now we will not going to get that error. So now there is only the DC analysis is there. These two are the constant voltages, and DC analysis, that will end here. DC analysis, we are doing only this DC analysis, and just run this now, and go to add traces, and here we need to add V in and V out, then click OK. So we will get something like this. This is the DC analysis, that means we can see, so V in, this is the V in, that is we are incrementing from 0, 0.1, 0.2, 0.3, and we are finding at what values. Okay, so this will going to like trigger from this. Okay, so now we need to find the this intersected voltage. Okay, so this voltage we need to find, so that is our cutoff voltage. Okay, so exactly come to this midpoint and find this cutoff voltage. Okay, so it is somewhere here. So either we can take horizontal or vertical, any voltage is fine. Okay, so we will take this horizontal voltage 774.615 millivolt. So just copy this. Okay, so then have that value. Okay, so now we made the DC analysis and we need to write that. So okay, let's open the text editor. Okay, so we need to, from DC analysis, what we observed, the cutoff voltage is 774.615 millivolt. Okay, so then we need to have this cutoff voltage values in the transient and the AC analysis. So now we will comment these two. Okay, just comment these two, and here uncomment this transient analysis Okay, only these two commands we have for the transient analysis. Okay, so now this is for the transient analysis, and here we need to provide this voltage. Okay, so here we need to provide 774.615 millivolt we need to provide here. So now this is 1M and 1K and dot tran of 100. Okay, so now let's find the, okay, so now we can save this and just run this, and so add the plot plane, add plot plane, and we in have it over here, and we out, and okay, so just increase this is just 100N, right? So just increase this to 10M and just run it. Okay, so now we can see this 10M, or okay, let's have this as a 5M. Okay, so 100N means it is too small, so just have like this. And now here we have the V in what we have V in the transient analysis. We have 1 millivolt. Okay, so this is the cutoff voltage that we given as a DC offset that we need to give for the maximum amplification. So then here 1M we have the input voltage, that means we just gave as a 1M. So from here to here, okay, so you can even measure from here to here. So just have the two cursor, one cursor keep it over at the top, and another cursor keep it at the bottom. Okay, so just keep at the bottom, and what the difference we are getting? So difference, we just need to see this vertical difference. Okay, so this is not horizontal, this is we are seeing from vertical, this top side to the bottom side, that means vertical. So that is voltage we are measuring, so that will be nearly 1.94. that means it has to be 2 volt, because here we have 1 millivolt, right? 1 millivolt, it is the peak voltage we are giving. So here peak to peak, from this peak to this peak, it is actually the 2 millivolt. It has to be 2 millivolt. This is V in, right? Yeah, this has to be, okay, so we'll just see it here. So 1.95 and okay, it has to be 2 millivolt, but okay, 1.94 something it is there. Let's consider as 1.93, and here, okay, just consider as 1.94 volt or 2 millivolt, anything is fine. We have to write this. Okay, so transient analysis. So in the transient analysis, V in is equal to as per this value we given, it is 2 millivolt. Let's take as a 2 millivolt. 1.94 means again calculation, so we just take it as a 2 millivolt, approximately 2 millivolt, and this is peak to peak, so it is just the double of this voltage. Okay, here if we give 1 millivolt, it has to be 2 millivolt, so just make it as double. And we need to measure the output voltage V out, that is equals to, so that we need to measure from the output waveform. Just go here and place this over to the one of the peak, and another one at the another peak, and what is the value we are going to get? So 28 point, okay, so just mod value we need to take. So what is the voltage we got? So we got 28.7826 millivolt. Okay, that is also peak to peak, peak to peak. Okay, so this vertical, okay, so from here to here, this V out we need to take, and that is, so then we need to find the gain. Gain is equal to V out by V in. Okay, so that is equal to 28.7826. that we just need to do in the calculator. Okay, so this is 28.7826 divided by 2 millivolt. Okay, so this is also millivolt and this also millivolt, so milli will cancel, divided by 2. So now this is what the gain we got, like 14.3913. Okay, so 14.3913 we got as the gain. So this gain we need to write it here, 14.3913. So this is the transient analysis. This gain we need to get the better gain, some what more we need to get. So for that you just keep the for this DC analysis, okay, this is fine, 774. Yeah, this is fine. 14.93. okay, how much we got, that one we're going to write. Just change the V in voltage to some other voltage, like 1 millivolt or 10 millivolt peak to peak, and just check it out. And in the AC analysis we need to find the phase and the frequency. So for that one, here we have this value, right? So in the transient analysis, this 774.615 milli, so that same thing we need to have it over here. Okay, so and now we need to comment down the transient analysis and comment out the AC analysis. Okay, so these two has to be there. So now, okay, so now let's save this and click run. So it will not give the proper output, so it will give something like this. So for this one, just Control A. Okay, so okay, so what we will do means simply copy this code, copy, just close this electric and again go to tools and set right spice deck. Okay, so come here and just okay, so from here we just need to paste what we have copied. Okay, so okay, we just lost that copy things, but yeah, we just need to do the analysis again, like not all these things, only the this analysis, last analysis. So for the AC analysis, what is the value we have? 774 point, this one we just need to have over here and just comment this down and this also. So now click run. Okay, just save this and click run and just have the address V in and V out, click OK. So now we can see we can see this AC analysis here. Okay, so we have this AC analysis here, and so now okay, so just go to here and 110G. Okay, so this is fine. And make this AC analysis. So this voltage, okay, 1K only, that's fine. So now what we need to find means, just select this V out, and here it is initially it is at here we can see the dB values, that is 23.48. when it started decreasing, so at this point, okay, till this it is 23.41, then it's just start decreasing. You can see that, carefully see here, okay, it will start decreasing at this point, okay, start decreasing at this point, so it is constant, yeah, start decreasing at this point. So now minus 3 dB, that means here it is 23.471, so minus 3 we need to do, that means 20.471. so just keep this to 20.471, 20.471, 20.46, okay, yeah, somewhere near. And we need to write down these values. This is the minus 3 dB, minus 3 dB, so we just need to write minus 3 dB, minus 3 dB at okay, so minus 3 dB at this value. And what is the phase? And phase is, what is the phase? 126.986 degree. And frequency 2.768 hertz, gigahertz, okay, it is not hertz, it is 2.768 gigahertz. FREQ, frequency, this is the gigahertz. So these values we need to note down, okay. So you may get this slightly different values based upon your cutoff voltages. So yeah, this way we need to measure all these three values. I hope you understood how to do this one. That's it. Yeah, thank you.